solubility. So generally definitions, they are asked for 1 mark. Second question, what is the effect of temperature on solubility of solid in water? Second, gas in liquid type of solution. Each carrying 2 marks questions. Now first, effect of temperature on solid in water. Now general observation, that is with increase in temperature, generally the solubility of solid in water increases. However, when we dissolve the solute in a solvent to form the solution, the formation of solution may be exothermic or endothermic. When the formation of solution is exothermic, according to Le Chatelier principle, here the exothermic process, the favorable condition is decrease in temperature. And therefore, here the effect of temperature depends on the enthalpy of solution, whether the formation of solution is exothermic or endothermic. If the formation of solution is endothermic, that is heat is absorbed when the solute is added to the solvent to form the solution, according to this Le Chatelier principle, increase in temperature is the favorable. So solubility increases with increase in temperature for endothermic process. If exothermic process is there, then what is the effect of temperature? If we increase the temperature, that will be the unfavorable condition. So if the temperature is increased, the solubility is decreased if the solution formation is exothermic. Followed. Now the next question, in summer aquatic animals prefer to stay at lower level in water. Why? So I explained this reason while explaining the effect of temperature on the gas in a liquid. So here, what is the effect of temperature on the solubility of gas in liquid? If the temperature is increased, the solubility of gas in a liquid decreases. And therefore, in summer, the top layer or top levels of the water, the temperature is higher. And hence, the dissolved oxygen is less, solubility of oxygen is less at the top level. But at the bottom level, here in the water, the dissolved oxygen is more as the temperature of lower level in the water is less. And that's why aquatic animals prefer to stay at lower level in the water during summer days. Is it clear? State and explain Henry's law. Here the statement that we have studied already, the statement of Henry's law, solubility of gas in a liquid solvent, it is directly proportional to the partial pressure of the gas above the solution. Now mathematical expression of the Henry's law, that is S is equal to Kh into P, where Kh is the Henry's law constant. Here state and explain the Raoult's law. So we have studied this statement, again its mathematical expression. Define ideal solution, non-ideal solution, vapor pressure. So all these definitions were explained while explaining the concepts. Write a short note on positive deviation from Raoult's law and negative deviations from the Raoult's law. So you have to explain the positive deviations from the Raoult's law with the help of graph. Here, this graph. Under which conditions the non-ideal solutions show the positive deviations? That is when solute-solvent interactions are weaker than the solute-solute and solvent-solvent molecular interactions. Under this condition, the vapor pressure of the solution becomes higher than that of pure components. And such a solution, it exhibits the positive deviation, which is shown by these graphs. So explain this with the help of graph. Secondly, similar to positive deviation, negative deviation, we can explain this with the help of this graph. Here, the solute-solvent interactions, they are stronger as compared to solute-solute and solvent-solvent molecule interactions. So in this case, the vapor pressure of solution decreases, and therefore solutions, they show the negative deviations from the Raoult's law. So you have to explain with the help of this graph. Followed. Now the next, the problem, that is numerical based on the Henry law. So this is the numerical from the exercise. Fish generally needs the oxygen concentration in water at least 3.8 milligram per liter for survival. What partial pressure of oxygen above the water is needed for the survival of fish? What is given? The solubility of oxygen is given at 0 degrees Celsius and 1 atmospheric partial pressure. Now this solubility is 2.2 into 10 raised to minus 3 mole per liter. So what is given whenever the numerical is there? First read the numerical carefully. Here write the data which is given. Solubility is given. Here the solubility of oxygen 3.8 milligram per liter. What is the unit of solubility? It is generally expressed in moles per liter. So convert this milligram per liter into the gram per liter first by dividing this 3.8 by 1000, so that it becomes 0.0038 gram per liter. When this mass is divided by molar mass of oxygen, that is 32 gram, here the solubility, it becomes 1.1875 into 10 raised to minus 4 mole per liter. Now we know the expression for the Henry's law. KH is equal to solubility S in mole per liter divided by pressure. Put here the value of solubility divided by 1 atmospheric pressure. So it becomes 2.2 into 10 raised to minus 3 mole per liter per atmosphere. Now we have to calculate the partial pressure that is needed for the survival of fish. Partial pressure of oxygen is equal to S upon KH. So here the value of Henry's law constant, it is 2.2 into 10 raised to minus 3 mole per liter per atmosphere, and the solubility which is in the mole per liter, this is solubility. Put these values in this formula so that after calculation that becomes 0.05375, which is approximately equal to 0.054 atoms. So in the board exam you have to calculate with the help of logarithmic table. Followed. Next, that is the next part in this chapter, solutions, qualitative properties of non-electrolyte solution. Now non-electrolyte means which doesn't conduct the electricity, means it doesn't produce the ions in the solution. Such a substance, it is called as a non-electrolyte. Next, that is, what are qualitative properties? The physical properties which depend upon the number of solute particles present in the solution and not on the nature of solute particles. Such a properties, they are called as qualitative properties. Now which are these qualitative properties? There are 4 qualitative properties: vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. Now we explain one by one. While dealing with these qualitative properties of the non-electrolyte solution, the dilute solutions with concentration 0.2 molar or less are considered. Now we see the first property, that is vapor pressure lowering. Now this vapor pressure lowering, before that, what is vapor pressure? So concept of vapor pressure, that was also already studied in the previous concepts in this chapter. What is vapor pressure? When liquid is kept in a closed container, there is an equilibrium between the rate of evaporation and rate of condensation, and the pressure exerted by the vapors of liquid on its surface at this equilibrium, it is known as vapor pressure. Then what is the meaning of vapor pressure lowering? Means there is a decrease in vapor pressure. Under which condition? When the solute is dissolved in a solvent. In this case, the solute is non-volatile. Now you are familiar with the word volatile and non-volatile. Volatile means it can be vaporized under normal condition. Non-volatile means it cannot be easily vaporized under normal condition. So here solute is non-volatile. So no vaporization here in case of solute. So whatever vapor pressure of the liquid, it is only due to the vaporization of solvent in the solution. So as the solute is non-volatile, it doesn't contribute to the vapor pressure above the solution. Therefore, the vapor pressure of the solution is equal to vapor pressure of solvent above the solution. We understand this concept. Now, when non-volatile, non-ionizable solid is dissolved in a liquid solvent, it is observed that the vapor pressure of the solution, means actually solvent in the solution, it becomes lower than that of pure solvent. That is the vapor pressure lowering. Now here, why the vapor pressure decreases when the non-volatile solute is added to the solvent? See here on screen, you can see this figure. Here in the first container, there is a pure solvent like liquid, water. In second case, this is the solution. Solution means there is a solute and solvent. So when non-volatile solute is dissolved in a solvent, some of the surface solvent molecules, they are replaced by solute particles. Here you can observe this. And therefore, the number of solvent molecules which are available for the vaporization per unit surface area of the solution, it becomes less than the number of solvent molecules present in the pure solvent. As a result, the solvent molecules escaping from the surface of solution is decreased when solution is formed, and this results into the lowering of vapor pressure. Here P1 naught, suppose it is a vapor pressure of pure solvent, and P1 vapor pressure of solvent above the solution. Then here we can write the P1 naught is greater than P1. So vapor pressure lowering, that is the difference between two. Delta P is equal to P1 naught minus P1. Is it clear? So vapor pressure lowering, it is given by delta means change in the vapor pressure. Here the vapor pressure of pure solvent P1 naught minus vapor pressure of solvent in the solution. That is the vapor pressure lowering. Now Raoult's law for solutions of non-volatile solute. Now Raoult, the scientist, he expresses the relationship between the vapor pressure of solution and that of solvent. What is the statement of Raoult's law? Vapor pressure of solvent over the solution. Because when the solution is formed, only solvent molecules, they are volatile, they can vaporize and go into the vapor state, and these vapor molecules exert the vapor pressure. Therefore, the vapor pressure of solvent over the solution, it is equal to the vapor pressure of pure solvent multiplied by its mole fraction in the solution. Is it clear? This is a statement. So according to statement, mathematically we can write P1 is equal to P1 naught into X1. P1 means it is the vapor pressure of solvent over the solution or above the solution. P1 naught means it is the vapor pressure of pure solvent, and X1 is the mole fraction of solvent. This is the mathematical equation, that is equation 1. Now you can see this graph, vapor pressure of solvent against the mole fraction of solvent. Now if you observe this first equation, P1 naught is a constant. The vapor pressure of pure solvent means when it is not present in solution, when it is present in a single form, pure form. So this is a constant value, and therefore P1 is directly proportional to X1. And hence, here when we plot the vapor pressure of solvent on the y-axis against the mole fraction of solvent, that is X1, here the straight line is obtained. Is it clear? This is the graphical representation. Now for binary solution, here we know this relation x1 plus x2 is equal to 1. x1 is equal to 1 minus x2. Here the 1 indicates the solvent, 2 indicates the solute. Now put this value in above equation, that is P1 is equal to P1 naught x1. So instead of x1, put this value 1 minus x2. Simplify this, it becomes P1 naught minus P1 naught x2. So P1 naught minus P1, rearrange this. It becomes equal to P1 naught into x2. Now what is this P1 naught minus P1? Just I explained. That is the difference between the two vapor pressures. This is the vapor pressure of pure solvent, which is always greater than vapor pressure of solvent in a solution. And therefore this difference P1 naught minus P1, that is the delta P, which is called as lowering of vapor pressure. So delta P becomes equal to P1 naught into x2, where x2 is the mole fraction of solute. Now this equation indicates that delta P also depends on the x2, that is the number of solute particles. The lowering of vapor pressure is a qualitative property. Is it clear? Here the relative lowering of vapor pressure. Now lowering of vapor pressure in relation to vapor pressure of pure solvent, and therefore the name relative lowering of vapor pressure. It is simply ratio, that is the ratio of lowering of vapor pressure to the vapor pressure of pure solvent. This ratio is known as relative lowering of vapor pressure. Now simplify, delta P is nothing but the P1 naught minus P1 divided by P1 naught. Now from equation 2, which is the equation 2? This equation 2, it is the delta P, yes, this equation. Delta P is equal to P1 naught into x2. So from this equation, rearrange delta P upon P1 naught, that will become equal to x2. That is mole fraction of solute. Here delta P, put this value as a P1 naught minus P1 divided by P1 naught. That is equal to the mole fraction of solute. Thus, the relative lowering of vapor pressure, in short we can say it as a RLVP. It is equal to mole fraction of solute in the solution. So relative lowering of vapor pressure also depends upon the mole fraction of solute in the solution, means number of solute particles in the solution. Therefore, it is the qualitative properties. Followed. So today we discuss the concepts. I revise in short. Here some sample questions that may be asked for the board exam. Short answer questions. One numerical based on Henry's law. What are qualitative properties? Definition of qualitative properties. Which are these 4 qualitative properties? Vapor pressure lowering, boiling point elevation, freezing point depression, osmotic pressure. From these qualitative properties, here I explained first, that is the vapor pressure lowering and relative lowering of vapor pressure. Vapor pressure lowering means when the non-volatile solute is added to the solvent to form the solution, here some of the solvent molecules at the surface, they are replaced by the solute particles, and therefore the number of solvent molecules which are available for vaporization per unit surface area of the solution, they become less when the solution is formed as compared to number of solvent molecules in the pure solvent. So this can be well understood with the help of this diagram. In pure solvent, the surface area, it is covered by all solvent molecules. They have greater surface area for vaporization. But when the solute is added to the solvent to form the solution, here the sum of the solvent molecules, they are replaced by solute particles. Therefore, here the number of solvent molecules which can vaporize becomes less. So here vapor pressure also becomes less as compared to vapor pressure in case of pure solvent. So that is the reason. Now mathematically we can write P1 naught vapor pressure of pure solvent, P1 vapor pressure of solvent above the solution. Then the change in the vapor pressure means decrease. Decrease in the vapor pressure equal to P1 naught minus P1, and this is known as vapor lowering of vapor pressure. Here the Raoult's law, that is the vapor pressure of solvent over the solution, it is equal to the vapor pressure of pure solvent multiplied by its mole fraction in the solution. That is the mathematical equation. After substituting this value of x1 as 1 minus x2, here the equation becomes P1 naught minus P1 equal to P1 naught x2. Again, here P1 naught is taken on this side so that it becomes P1 naught minus P1 is equal to delta P, that is lowering of vapor pressure. So this shows that delta P depends on x2, that is number of solute particles. It is a qualitative property. Relative lowering of vapor pressure. Here it is the ratio of lowering of vapor pressure to the vapor pressure of pure solvent, that is delta P upon P1 naught. Here from previous equation 2, we can write delta P upon P1 naught equal to x2, that is P1 naught minus P1 divided by P1 naught. So here also we can observe relative lowering of vapor pressure. It is also qualitative property as it depends upon the mole fraction of solute in the solution.